Hello! This patch is an extension of the idea I talked about in the last video I posted about getting extra LFOs on the Matriarch. In fact, the idea for this patch came while making that video, and although a few weeks have probably passed since I posted that video, I just set to work on this right away because I was really excited to try this out. So the idea is to use the VCOs on the Matriarch as clock generators, and that's what we're listening to now. This doesn't have to be a big long intro. I'm going to put together 3 or 4 patches using this idea and show some alternate ways of getting the same or similar results. And I'll also go into a little bit of theory at some point to explain what's going on. I think this idea has a ton of potential and I'm really looking forward to exploring this. I'll put an index in the description, but before I get to the patch walkthroughs, here's a quick sample of some of the things I came up with. Alright, let's get started. We're going to use oscillator 4 as our first clock. We can use a pulse or sawtooth wave for this, and we'll bring the octave all the way down. And just like in the last video, we're going to use an attenuator to offset the pitch to bring it down into LFO rates. So just patch out of the attenuator into the pitch input, and the attenuator will control the offset amount or the rate. And I'm patching wave out of the oscillator into a mult, and from the mult we'll go into the trigger input of each of the envelope generators. So now our oscillator's triggering the envelope generators, and we can control the rate with our offset. Typically a gate or clock signal is a unipolar pulse wave, but as you can hear, the sawtooth wave I'm using now is working fine. In fact, if you've used up all your envelope generators and you need to modulate a VCA, sawtooth wave will work in a pinch. Sounds like an AD envelope with 0 attack. Okay, that sounded like it was around 90 BPM, and I'm not all the way down on my offset, but if I did want a slower gate or clock signal, I could take advantage of the internal relationship of attenuators 1 and 2 and offset the rate even further. Let's see how slow this thing will go. So I've patched wave out of the attenuator back into the mult. There's our first trigger. Let's time this. Okay, this could be a while. Let's get some waiting music. Okay, 27 seconds or so between triggers. That's pretty slow. Probably not that useful as a clock, unless perhaps you want super slow triggers for some ambient music or something. Anyway, just wanted to show you that. Let's bring it back up to a reasonable tempo. Let's try a little faster. I think that's around 100 BPM. No, it doesn't matter. We'll go with that. Now check this out though. I started with C1, but if I hit C2, our clock is now twice as fast. C3, of course, we're 3 times as fast, and you guessed it, C4, 4 times as fast. So the oscillator is obviously key tracking, but why are we getting such clear divisions? Well, time for some theory. The frequency of C is 65.41 Hertz, or cycles per second. You know what? I don't want to do this with C. The math is going to be too hard. Let's use good old A440. Much easier math. It'll be the same for any note, so might as well make our life a bit easier. The frequency for an A an octave up is 880 Hertz. 4 octaves above A440 is 1760 Hertz, or 1.76 kilohertz. So it's pretty obvious to see what's happening here. 880 is twice as fast, or twice the amount of cycles per second as 440, and 1760 is 4 times as fast. So each octave will be an even multiplication of the octave below. So now that we've done all the math, we can forget it and just use music theory to figure out how to get clock multiplications. Now, of course, we don't have to use just even multiplications. If we want dotted or triplet rhythms, we can play other notes. An augmented fourth or diminished fifth or tritone or devil's interval, whatever your name for that interval may be, divides the octave in half. So no need for math this time, just think of a flat 5 as a multiplication by odd numbers. And again, octaves are even numbers. So if C1, for instance, is my quarter note value, C2 will be eighths, C3 will be sixteenths. But if I play an F sharp above C1, or multiply the frequency by 1.5, I'll get dotted eighths. An F sharp, an octave above that, will multiply the frequency roughly by 3, and I'll get triplets. So let's try it out. All right, that's fun and weird. Love it. Okay. Now, just so you know, we don't need to use our oscillator to do this. We can key track our LFO, for instance, to do the same thing. So let me just show you how that works. Just going to unpatch this for a second, and I'll patch directly into the wave out of my LFO and keyboard CV out into the rate input. So in other words, I'm just key tracking my LFO. Speed it up a bit. And let's try it. Yep, works fine. Cool. Only trick is you gotta make sure that you're playing in time. But works fine. Okay, let's see what happens if we try to key track the sequencer, for instance. So I'm going clock out or gate out, of the Arpeggiator and keyboard CV into rate input. So it's not 1 volt per octave tracking, so we're not getting the same divisions. So that's not going to work quite as well. Oh well, worth a try. Okay, back to our patch. I put everything back the way it was, but let's do a quick summary. We're using oscillator 4 as a clock source. I've got it set to its lowest octave and have now switched over to a pulse wave. But to slow it down even more, I've patched the wave out of the oscillator into the input of attenuator 1. Attenuator 1 and 2 are internally linked on the matriarch. If nothing is patched into the input of attenuator 2 acts as an offset for attenuator 1, so we're offsetting our rate even more, as you saw earlier. The output of attenuator 1, our clock signal, is patched into a mult and out of the mult to the trigger inputs for both the envelope generators. And this time around, I'm going to patch a dead patch into the pitch input of oscillator 3. For the moment, it's not doing anything, but if we decide to modulate the pitch of oscillators 1 and 2, the dead patch in pitch input 3 will stop any modulation from affecting oscillators 3 or 4. Okay, let's get it going. And now let's mess around with the pulse width of our clock. This is something you can't do with the LFO or the Arpeggiator. So I'm going to patch the output of an attenuator into the input of the pulse width modulation for the oscillator. So what we're essentially doing is modulating the gate length of our clock. Pretty cool. Let's just set up a better sound here. Cool, you can hear that. Longer notes and shorter notes. You know what, I misspoke. This is something you can do with the Arpeggiator or sequencer on the matriarch, but you have to use MIDI. I did a video about that almost a year ago now. You can check that one out. Okay, so let's set up some modulation so we don't have to manually turn the attenuator. So I'm just using a Splix, which is a passive attenuator, out of the LFO into the CV control input for our attenuator. And let's dial in some sounds. That's pretty cool. That was easy. Yeah, I like that a lot. Long and short notes, pretty cool. Just mess around a bit, see if we get anything better. Nope. Oh, that's neat. Cool. Now we're getting some rhythmic variation and some rests introduced, which is pretty cool. I should have set up my scope to show you what's happening, but basically the PulseWidth is being modulated and cut off, so it's not long enough to trigger the envelope, and that's why we're getting rests. Now we're still faced with the problem that our oscillator is going to key track. See, it's slower if we're going down. So that's not that useful in this kind of patch if we wanted the sort of like a repeating bass figure that we could transpose. So let's sort that out. Going into good old global settings here, I'm going to turn off local keyboard control. This is C#2, D#1 and hit C0. Now our keyboard has no effect. And keyboard CV out to pitch in on oscillator 1. And now our clock will remain the same tempo thanks to our dead patch, but we can transpose our sequence. Cool. So, well, the application for this is pretty obvious. You know, you can use it as a brainstorming tool for figuring out some new rhythms that you might not have thought of, or live playing. This is an easy way to get some rhythmic variation in your patches. And you can mess around in real time, which is awesome. And you don't need to use MIDI. And of course, it's just a lot of fun. Nice. Okay. On to the next idea. So I'm just going to get rid of this LFO modulation here for now, and PulseWidth modulation. Get rid of the keyboard tracking, and I'm going to go into global settings and just reset everything to default. Okay. Actually, let's make sure that works. Yeah, we've got keyboard control back again. We're all good. Okay, I'm going to remove the dead patch here. We're not going to need it for now. And I'm going to take oscillator 4 wave out of the attenuator, or clock signal, of course, and patch it into a mult. And we don't need this attenuator. I can get rid of that for now as well. And I'm going to take the Arpeggiator clock input off the back of the Matriarch and plug it into our mult. So the Arpeggiator is now being clocked by the oscillator. And because we've got Keytracking back on, you can see we're getting our multiplications again. Because we're clocking the Arpeggiator now, we don't have to be as precise with our key presses, so you can play out of time and it will still work, in other words. But there's a few other advantages. Let's check this out. Using pitch, we now have rhythmic variations in our Arpeggiator. Let's change the play direction. That's cool. Now if I put in a minor 7th, we'll get a real lazy swing feel. And it's pretty lazy. Yeah, that's real laid back. Let's try a few other things just for fun. Let's see what happens if we play a diminished chord. That's cool. So diminished chords divide the octave into 4. That's kind of neat. Let's add the root on top of that and change the play order. Yeah, that's really neat. Let's put an octave down low. Oh, that's kind of cool too. Okay, cool. Well, you get the idea. We've now got rhythmic control over our Arpeggiator. That's pretty cool. Something worth messing around with. Okay, but let's see how this works with the sequencer. Obviously, it's going to be the same as the Arpeggiator, but we could program and save a sequence or rhythmic sequence we like. So just use tritones again. Yeah, that's okay. Let's try something else. A little less weird. In 7/8. Let's just see what some of these pre-programmed sequences sound like. That one's cool. I think I'll stick with the one in 7 for now. 7's not so weird. But you've probably figured out the problem here. If we hit other keys, it's going to speed up our sequence, which might be a cool thing. but probably not for most applications. Okay, so let's see if we can sort that out. We're going to go back into good old global settings again, and this time we're going to turn off local ARP control, C#2, F#1, C0, and back in again, and we're going to turn off local keyboard control again, C#2, D#1, and 0. And now I'm going to turn off sequencer control. Oop, not in global settings. Let's sort that out. Okay, sequence keyboard control off, D#2, A#0, C0. Now, if you're doing multiple global settings like this, like I just did, you don't have to keep leaving global settings. It's just a habit I've developed. If you don't hit the modifier key twice like I do, you'll stay in global settings. You can keep changing things. So now I'm patching CV out of the arpeggiator into the CV control input for the attenuator, which is controlling the pitch of our clock, or the rate of our clock. And patching the gate out of the arpeggiator into the molt, which is again going to be patched into the trigger inputs of our envelope generators. And the keyboard CV into the pitch input of oscillator 1, and we're going to need a dead patch again. So now we should be able to transpose our rhythmic sequence without it changing its tempo. Just sort out the tone first, not crazy about that. Okay. It worked. Fantastic. Let's play around a bit. So you can, of course, just program a rhythmic sequence into your sequencer, but you can't get triplets and you can't change the gate length. So we have some advantages doing it this way. Cool. Okay, let's just program in another sequence just for fun and see what happens. So remember, the pitches that you program into your sequencer won't be affecting the pitch of the sequence, but they will be affecting the rhythm that comes out. So I just wing that, so hopefully it's okay. Nice. So this is a real easy way to get dotted or triplet rhythms. It is possible with the Matriarch sequencer. It's just a real pain in the butt. And of course, now we have transposing control again. So it worked out. That's a pretty cool patch. Okay, another patch idea for you. Up until now, I've only been using one oscillator as a clock, but obviously we have 4 on the Matriarch. So let's make a patch with 4 different clocks. We're essentially going to be using the Matriarch as a gate sequencer, kind of like a simple version of Pamela's new workout. So let's go through this setup. All 4 oscillators are going to act as clocks, so we need to bring them down to LFO rate and offset the pitch. It's the exact same idea as before, using an attenuator as a DC offset, but this time I have it patched into the pitch input for oscillator 1. We don't need to offset the other oscillators because the Matriarch's internal routing will carry that offset through to all the other oscillators. In this case, I don't need to use attenuator 1 to offset further. We're not going to be needing super slow speeds. Because we're using all oscillators as clocks, we need some sound sources. So I'm going to use the utility LFO as a VCO. So I have the keyboard CV out from the back of the Matriarch patched into the rate input on the LFO. The LFO wave out is patched into the oscillator 1 input on the mixer. For this patch, I want 2 independent voices with their own filter, envelope, and VCA. So I have the mixer out patched into VCF2 in. So filter 2, VCA 2, and the amp envelope generator will all be used for this voice. For the second voice, I'll use noise as the sound source. So noise out of the mod bay to VCF1 input. VCF1, VCA1, and filter envelope will all be used for this voice. Back to our oscillators, or in this case, our clocks. I'll start with oscillator 2 clocking while triggering the envelope for the noise voice. So oscillator 2 wave out to trig input on the filter envelope. Oscillator 4 wave out to trigger input on the amp envelope. I've also got some modulation to set up. So wave out of the mod bay LFO to a molt. 1 copy is going to be used to modulate the cutoff of the noise voice. So it's patched into the filter cutoff input for VCF1. It's being attenuated by another Splix. I get asked about these Splix things all the time. They're just passive mixer attenuators. The brand I use, once again, is called Splix by Board Brain Music. You can get them, or things just like them, from pretty much any synth shop, or you can buy directly from Board Brain Music website. I'll put a link in the description. Oh, another thing. I'm modulating the cutoff of filter 1. I don't want that to affect filter 2. So if you've seen my filter videos and how they work on the Matriarch, you'll know that we need to put a dead patch into the cutoff input for filter 2, or else filter 1's going to affect them both. Anyway, back to our modulation. The other copy from the mold is going to modulate the pulse width, or in this case, gate length of oscillator 3. So it's patched into the CV control input for attenuator 3. The output of attenuator 3 is patched into the pulse width modulation input for oscillator 3. Okay, a few more things to do before we get this going. First thing I need to do is make sure that all the oscillators are at the same pitch, so I need to go into global settings again and turn local keyboard control back on for a second. C#2, D#1, and D turns them back on. Going into unison mode and hitting a low C, which should make all the oscillators tuned to low C. And going to turn local keyboard control off again. So that's C0 this time. So again, our clocks are not going to be affected by the keyboard, but we're just making sure that they're all at the same pitch. Now I'm going to turn on oscillator sync and make sure all the oscillators are synced to oscillator 1. But I guess we should make sure we know what oscillator sync does. The Matriarch manual does a much better job of explaining it than I ever could. When two oscillators are synced, the first oscillator behaves normally while the phase of the second or synced oscillator is forced to reset its cycle to match each new cycle for the first oscillator. This synchronization caused the waveform of the synced oscillator to take on a more complex wave shape as it works to align with the first oscillator. Sync is useful for creating sharp metallic and flange-like sounds, while also ensuring the pitch of the synced oscillator stays locked to the pitch of the first oscillator. That's a pretty clear explanation, thank you Moog, but let's see how this actually works. I've got two oscillators patched into my scope. The trace on the bottom is the master. That's the one that in the manual Moog explains behaves normally. It's the oscillator that the others are synced to or slave to. The top trace is an oscillator slave to the first. So let's see what happens as we increase the frequency of the synced oscillator. At a certain point, you'll see that the wave is perfectly multiplied by 2. You can hear that the pitch of the synced oscillator is now an octave above the master. As we increase the rate further, we can get even more wave multiplications. Okay, we're out of room there, but of course we can use our octave button, or octave switch, sorry, and get even more. And of course, the most fun with oscillator sync is sweeping the frequency. Cool. That's obviously the flangey metallic sounds they're talking about. You may have noticed that the synced oscillator is kind of following the overtone series. If you watch my video about the subharmonics and recreating a subharmonicon, you may have seen the section about overtones. I go into a lot of detail about the overtone series and subharmonic series. You can check that out if you want. But all you really need to know is that overtones are multiplications of the fundamental frequency by whole integers. In this case, it simply means we can use our ears to identify the overtone series and therefore easily sync our oscillators to multiplications of the fundamental. That still sounds complicated. In plain English, we can use oscillator sync to evenly multiply the frequency of the master oscillator, and therefore we can get clock multiplications that will be in time. So let's try this out. Oscillator 1 is the master and it's triggering envelope 1, which is modulating VCA1. Oscillator 2 is the synced oscillator and it's triggering envelope 2, which is modulating VCA2. Oscillators 3 and 4 are patched directly into the VCA inputs for now. Let's check this out on the scope. Okay, let's increase the rate of the synced oscillator. And you can hear that we're getting kind of a wonky swing feel now. That's cool. But if we keep going, we can eventually get, there it is, perfectly in time, 8th notes. And some more wonky time feels until we find our next overtone. There we go, now we're getting triplets, multiplied by 3. I'll keep going, but you get the idea. Now we're getting 16ths. A weird wonky time feel. Oh, 5 tuplets. University, university, university. Anyway, you get the idea. We can use oscillator sync to keep our oscillators in time and get some nice even multiplications. Awesome. Okay, back to our patch. And let's take oscillator 1 wave out and plug it into a mult. And out of the mult in the clock input on the back of the matriarch. We obviously don't need a mult for this, but I might use this signal to do some other things a little later on. So oscillator 1 is clocking the arpeggiator. And to start the patch, I'm going to get rid of the modulation. We'll add that in a second. Just want to hear it clearly first. So oscillator 3 is clocking the LFO and oscillator 4 is clocking the noise. Let's try increasing the frequency. Get some different rhythms. Oh, there's some triplets. 16ths. And if we adjust it a little bit, we can get some sort of out of time wonky 16ths. That's cool. Anyway, let's just put it back to quarters for now. Okay, and I'm just going to move the clocks over to oscillator 2 and 3. I might use oscillator 4 for something else. Really doesn't matter, I guess. And we're going to get our modulation going again, so I'm going to use the gate out of the arpeggiator to sync the rate of the LFO. I'm going to pull that out for a second so we can just work on the noise. And I'm going to go into global settings. And I'll turn off local ARP control just to make sure it's off. C#2, F#1, C0. Pretty sure it's off, but we've got to make sure. And going back into global settings, and now I'm going to turn on keyboard CV mirrors ARP sequence CV. So now my little LFO VCO will be controlled by the sequencer and arpeggiator too if I want. Okay, let's work on that noise a little bit. And I'm going to patch the modulation into the VCF. And voila! Instant dance groove. Pretty cool. We can get a kick and hat just from modulating the filter. Sweet. Just adjusting the spacing a little bit to get a sound I like a little bit better. Spacing, of course, is just controlling filter 1's cutoff. Okay, that's sounding good. Let's get the other voice going again. Can't remember which one I'm using as its clock. Oh, there it is. Oscillator 2 into trigger input. Oh. And adjust the frequency so that they're in time. So I'm using oscillator 1 again as the master clock, but oscillator 2 is triggering the bass sound. So I have independent control over the rate of the bass. In other words, I could make him play eighth notes if I wanted, or double notes. But let's set up our PulseWidth modulation and see what we get going. Nice. That's cool. And of course, we can easily transpose our sequence because we're using the arpeggiator. Cool. It's a pretty neat little patch. Just gonna experiment a little bit before I show you one more idea. Okay, I think this might be the favorite patch I've come up with in a long time. There's so much potential for this. It's still brand new to me, and I'm looking forward to exploring this one a lot more, but even with just a limited time I've had with it, I'm pretty pleased with the results. Anyway, we've got 4 oscillators. At the moment, I'm really only using 2 of them to clock sound sources, so the next obvious thing to do would be to add more sound sources, or things for the oscillator clocks to modulate. In past videos, I've showed you a few tricks to help you get around the fact the Matriarch has only 2 VCAs. We've talked about using the attenuators as VCAs, or sending signals directly out of the wave outputs to a mixer or audio interface, or even using the filter as a low-pass gate. But this time, I'm going to take the easy way out and use the oscillators to clock other synths. So I'm going to use our master clock, oscillator 1, to advance a sequence on the Moog DFAM. And I'll use oscillators 3 and 4 to trigger envelopes on my Roland System 500. I'm going to molt the output of the clocks, send them to a logic module, and send the output to a quantizer, which will then modulate the pitch of both of the oscillators on the Roland. So we'll get some random melodies and arpeggios from the Roland, which are directly related to the rhythms I create with the oscillators on the Matriarch. Pretty cool. And I'm also going to modulate the pulse width of one of the Roland clock oscillators, oscillator 4, with the output of the Matriarch's mod bay for more rhythm and pitch randomization. So the Matriarch is acting primarily as a gate sequencer in this patch with real-time control, but it's also, of course, the sound source for the bass and percussion like we just patched a minute ago. Before I try this out, I'd like to thank you for watching. Hope you learned something or inspired to try some ideas out. And I guess that'll do it. So let's try this out.